Hello everyone. In this video, we are going to study nuclear magnetic resonance spectroscopy, commonly known as NMR spectroscopy. NMR is one of the most powerful analytical technique used in a chemistry for structure determination or and identification of organic compounds and studying molecular dynamic and bonding. It is widely used in organic chemistry, medical chemistry also, biochemistry and the material science also. Basic principle of NMR. The principle of NMR is based on the magnetic properties of atomic nuclei. Only nuclei that have non-zero nuclear spin, L is equal to non-zero. So NMR behavior, like for example, NMR, what is NMR active nuclei? H1 proton, C13, F17, P31. Example of NMR inactive, for example, carbon 12 or oxygen 16, etc. Nuclear spin and magnetic moment. A spin nuclear behave like a tiny bar magnet due to its magnetic moment. When such a nuclei are placed in an external magnetic field, then we call as a B0. They align with or against the field. This products different energy levels. Here also you can read the principle of NMR, interaction between electromagnetic radio waves and matter. Okay, and then remember, then this is graph of the absorption and frequency. This is a formula you can recall. Next, nuclear quantum number, you can hear and remember this. Here resonance condition also, when radio frequency radiation is applied, nuclei absorb energy and move from lower energy state to higher energy state. So you can remember this. This absorption occurs when the energy of state or energy of RF radiation matches that the energy of gap, that is delta E is equal to HV. This condition is called resonance, hence the name nuclear magnetic resonance also. Are you see this notes and extra? This is Larmor precisions and Larmor frequency also we can indicate. In a magnetic field, nuclei do not remain static. They process around the magnetic field exist. The frequency of motions is called Larmor frequency. Is we call V0 is equal to gamma, B0 is equal to 2 pi, where gamma is equal to gyromagnetic ratio or B0 is equal to external magnetic field strength. Higher magnetic field to higher resolutions NMR spectra. Okay, this is elements that give an NMR spectra. You can remember nuclei in magnetic field, what we can read, absorption, and I can remember. And also this is NMR instrumentation. This is figure, magnet, single detector, recorded outmet, what is work in magnet, field swap generator, ratio frequency source, signal detector, recorded output. You can see here also sample holder, roller probe, NMR instrumentation techniques also included in this study of NMR spectra. Why? Okay, so this is it. In NMR, chemical shift is very important. Not all nuclei absorb RF radiation at the same frequency. This is because electron around the nucleus shield it from the external magnetic field. Chemical shift definition we call as a chemical shift is the relative position of an NMR signal compared to a reference compound. You can see this definition is very important for your exam. It is expressed in a ppm for a parts per million. Reference for compounds we called as a TMS, tetramethyl TMS is used as a reference because all 12 proton are equivalent. Signal appear at 0 ppm or chemically inert and volatile. So chemical shift formula is equal to, you can remember, okay? Here equivalent and non-equivalent protons, or you can see here is one signal. If both are same, so signal is different, not okay, same to one signal, different to second signal. You can recall and remember this. Enantiomeric and determintomeric protons, you can remember, okay? And see his. Next we discuss shielding and deshielding of proton. Shielded protons means high electron density, appear upfield or a low delta value, okay? Deshielded proton means near a electronegative atoms or a pi system, appear in a downfield. Here high delta value. For example, alkane protons has a 0 to 2 ppm. Aromatic protons have a 6 to 8 ppm, or aldehyde proton has a 9 to 10 ppm also. Okay, you can remember this chemical shift, or its formula is delta. We can, I also remember this delta is relative position of sample proton divided by frequency of applied magnetic field into 10 raised to 6 ppm. Okay, cause of chemical shift: electropositive nature or inductive effect or hybridization, size of ring, unsaturation, benzene or aromatic protons, acid group, hydrogen bonding, effect of solvent and acidic, proton attached to heteroatom. You can see and very confirm this, okay? First of all, we can remember this point as spin coupling. This we call as a J coupling. You can remember protons influence each other through a bond interactions or a causing signal splitting also. N plus 1 rule here we can use this. If a proton has a n neighboring equivalent protons, its signal split into n plus 1 peaks, okay? You can remember this formula. Neighboring proton is 0, so signal type is singlet. If a neighboring proton is 1, so signal type is doublet. Neighboring proton is 3, so signal is triplet. And neighboring proton is 3, so signal type is quartet. Coupling constant J is what? So for a distance between split peaks or a measure in Hz, independent of magnetic field strength, or indicates bonding relationship, etc. Interrogation of signals. You can remember the area under an NMR peaks is proportional to the number of proton during that signal. Integrated helps to determine proton ratio or confirm molecular formula also. Okay, this is magnetic anisotropy. They all are shielding, deshielding effect. You can remember, listen carefully, read carefully, and this is help for your exam and studying also. Relative intensity of a signal, you can remember. And also we can spin coupling, okay? This all are notes is very helpful for your exam and study also. This is very easy English for coupling constant we studied. And vicinal protons or geminal protons, vicinal protons, long range protons of oxygen, phenols also, okay? Here difference between spin coupling constant or chemical shift also. Determinants labeling, what is labeling, and triplet. Now I can discuss of application of NMR spectrum for identify olefin proteins or a hydrogen bond of NMR atom. aromaticity, or a keto or anofield application of, you can see these all are helpful for you. Okay, and remember also this is very helpful for you. This is conformational analytical NMR. Here we can discuss also H1 NMR spectrum interpretations for a stepwise approach when the solving an exam problem. First of all, we count a number of signals, okay, number of proton in environments. Second is check chemical shift type of proton. Third is analyze the splitting neighboring protons. Fourth one is use the integration protons count, and fifth one is combine all data, and then we call structure determinations. In this we use a 1H NMR. Next 13C NMR spectroscopy. In the brief we use a 13C isotopes 1.1 percentage abundance, or a signals appear over and wide range 0 to 220 ppm. No splitting, usually proton decoupling, or its signal represent one carbon environment. Carbonyl carbon appear at a 160 to 220 ppm. You can remember this. Advantage of NMR spectroscopy is very easy for non-destructive techniques, or highly informative, or applicable to solid, liquid and solutions also. Provide complete structural information. Some limitations of NMR, we can say expensive instrumentations. Second is less sensitive than the mass spectroscopy, and then third is require strong magnetic field. So this all are limitations. Importance for exams questions for MSc. Explain the principle of NMR spectroscopy, or derive the resonance conditions, or what is chemical shift, or explain shielding, explain spin coupling with example, interpret a simple H1 NMR spectrum, or a complete H1 or a 13C NMR. Here all are important questions for your exams, and you can remember and also find the answer in this chapter. Conclusion is the NMR spectroscopy is a core topic in MSc chemistry, and guarantees marks for if concepts are clear. You can easily remember them. And new definitions, diagram, examples, stepwise spectrum interpretation. For always draw tip for exam, you can always draw energy level diagrams, splitting patterns, and label ppm value also. Okay, here this chapter is exercise is useful for your exam. Okay, thank you so much.